also, within the same context, let me ask the following question. Can a person get 110? Well, for y equal 110, we can find the x numerical value by a simple replacement. 110 equals 5 times x, and so if we divide both sides by 5, I'll end up with x is equal 22. So keeping in mind that x is the number of correct answers on a certain test, and that test contains 20 questions only, is it possible to answer 22 questions correctly out of 20? Of course not. That is very obvious. And so y values in this case cannot be any numerical value one can think of. In fact, y values have also some restrictions on them. That restriction is called the range of the function. And so by definition, the range of a function is the set of all possible values of the dependent variable, and in this case we are labeling the dependent variable by y. So the question, so going back to the graph that I have, I am going to erase this portion from here because this portion is not related or not representative to the problem in which the question is being posed. In this particular problem, not in general, because that relationship y equal 5x, can be a representation of another problem where x can take on negative numerical values. Just in this problem, we can do that. And so now we have the idea of domain and range. The question is, how do I find the domain and range of a certain function? To do that, I'm going to use a particular example, or at least two examples that enable us to find the domain and range of a function. So we'll start with something like y equals 15 over x minus 3. In order for me to find what is the domain of this function, I ask myself the following question. Is there or are there particular x values that, when substituted over here, the y values are not generated? Let me rephrase my question. Is it possible to find a number that, when I replace x by that number, there is no possible value for y? Is there a y value for x equals 0? If I replace x by 0, then y is equal 15 over 0 minus 3, which is negative 3. So there is a y value for the x value 0. So I ask the question again. Can you find an x value for which y does not exist? Absolutely, it's very easy to figure out that if an x is equal to 3, y would be equal 15 over 3 minus 3, which is 15 divided by 0. This quantity, this ratio, is undefined. How can you divide something by 0? And so any other value for x in this context is permissible. We can use it, except the value x equal 3. And so we say the domain of this function is, we can represent the domain in two different ways. We can say it's all real numbers except the singleton 3, because that's the one that I cannot use. Or I can say the domain of x is the set of possible values, everything from negative infinity, the smallest possible number you can think of, until 3, but 3 is not included, and from 3 to positive infinity. Some books use only infinity to represent positive infinity. And so this means all the numbers except the 3. The parentheses means that this boundary of the interval is excluded from the solution. Okay, so now that we've done the domain of this function, it is important to follow it up with the range of the function. Remember, range is the set of all possible values of the dependent variable y. So you think about it this way. Is there a possible value for y that cannot generate a value for x? Or is there a certain numerical value for x that does not give me, let me rephrase that. Is there a numerical value for y that if I replace that number here by y, there is no x that matches that? So let's think about it this way. Okay, could y equal 1? If 1 is equal 15 over x minus 3, then I can cross multiply and I can find the numerical value x equal 18 to work with that. Okay? Any other numerical value you can think of? Can you think of a numerical value that if I put over here and I get 15 over x minus 3, then this number over here, okay, does not generate an x value. Basically, I want x to disappear. That is correct. If you had put a 0 over here, then what happens is, if you cross multiply, you're going to get 0 times x minus 3 is 0 is equal to 15. Is this a correct mathematical statement? Of course not. So the numerical value y equals 0 is impossible no matter what x is. In fact, think about it this way. You have $15 and you're distributing that, because division is distribution, over a certain number of people. That number of people is represented by x minus 3. No matter how huge that number is, suppose you want to distribute it over the population of your city, of your country, of the whole world. Yes, technically, practically, nobody's going to get anything. Imagine dividing $15 by 6 billion people. But mathematically speaking, if you divide 15 by no matter how big the number is, the answer is going to be a number. An extremely small number, I agree, but it is not equal to 0. Maybe 0.100,000 zeros 1. Still, it is a numerical value, and it's not equal to 0. So the value of y cannot be 0, and therefore the range of this function, again, we can represent it in the same way, either r minus the singleton 0, some textbook use the term r star, which is r minus the singleton 0, or from negative infinity to 0, and from 0 to infinity, excluding the 0. So, I would like to ask the following question. Within this particular function, can you find a way, because we're not going to guess. I mean, let me try x equals 0 and x equals 5 and x equals 9, etc. Within this particular function, can you find what is the way